Welcome to lesson 6.2 for pre-calculus. So today we're going to learn about the law of cosines. Previously we just learned about the law of sines and saw the different triangles that the law of sines could be helpful for. Today we're going to learn a few more formulas specifically pertaining to the law of cosines. So my first question to you is, when would you actually want to or need to use the law of cosines? So we have an oblique triangle that does not have a right angle. When we are going to use it is when we have all the three side lengths, so side, 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 or if we have side, angle, side. So the angle that we have is in between the two different sides that we're given the lengths of. So if we have either of those two situations, then we're going to have to start out using the law of cosines. So we have lots of formulas for you to write down. And honestly, as soon as we get done with the formulas that are written here, I would pause this slideshow and just copy those down onto your notes. So the first three formulas are given when we have two different side lengths and an angle. And we're able to figure out the third side length with those pieces of information. So for example, if we wanted to solve for A, so this side length right here, we would use this following formula where we have b squared plus c squared minus 2bc times cosine of angle A. So in this formula, we're given this piece of information, side length B, and we'd have side length C and angle A. So we have side, angle, side, and we're able to solve for the third side length here. So we have variations of this formula just given whatever pieces of information we have. So for example, if instead we had the side length of A and the side length of C and the angle cosine B, then we would be able to solve for the side length B squared over here. So you can see that these formulas are very similar. It just depends on what pieces of information you have. So here we're solving for B squared, or for side length B, we have A, C, and angle B. So the third formula, you can probably guess, is going to be very similar to this, but that's where we're going to solve for side length C. And that formula is c squared equals a squared plus b squared minus 2ab times cosine C. So again, if we take a look at our triangle, that means that we would have side length A, side length B, and angle measure C. And then we would be able to solve for side length C. So the next three formulas that you're going to see are just algebraic manipulations of these three formulas right here. And we're going to be rewriting it in terms of cosine A, cosine B, or cosine C. So the first formula that we have is cosine A equals b squared plus c squared minus a squared all over 2bc. The next formula is cosine of B equals a squared plus c squared minus b squared all over 2ac. Last formula, cosine C equals a squared plus b squared minus c squared all over 2ab. So these are the formulas that you have for the law of cosines, and you can see that they're very similar to each other. It's just a matter of what pieces of information that you're given. So if you have two side lengths and an angle, so we have side, angle, side, we're going to use these first three formulas here, depending on which piece of information you're looking for. If you have all three side lengths, so you have side, 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 you're going to be using one of these three formulas down here, so where you're solving for the actual angle. So those are your formulas that you're going to use. Let's actually put these into some practice here. So our first example here, we're given the three side lengths, and we need to find each of the angle measures. So let's take a look at this triangle and actually write down the information that we have. So we know that side length A is 55, side length B is 25, and side length C is 72. We need to solve for each of the angle measures. So we're going to first start out using our law of cosines formula to find the measure of angle A. So remember, that formula is b squared plus c squared minus a squared all over 2bc. So we're just going to plug in all of the information that we have. So cosine a equals b squared, so that would be 25 squared, plus c squared, so 72 squared, minus a squared, so minus 55 squared, all over 2 times 25 times 72. So when you put all of this into your calculator, you end up getting that cosine of A equals 0.7733. So now that we have this piece of information, we can use our inverse function to find out actually what the measure angle of A is. So we're going to plug into our calculator now cosine inverse of 0.7733. Make sure that you have it in degree mode because it's easier to read it in degrees. And when you plug that into your calculator, you end up getting that measure of angle A is 39.3 degrees. Okay, so now that we have the measure of angle A, we can actually use the law of sines, which is a little bit easier so we don't have to deal with all of these fractions and squaring to find the other angle measures. So we're going to use that for measure of angle B. So remember, our law of sines was a ratio. So we can put sine of 39.3 degrees over its side length, which is 55, equals sine of B over its side length, which is 25. So we end up getting sine B equals 25 times sine of 39.3 degrees all over 55. So when you plug that into your calculator, you end up with 25 times sine of 39.3 divided by 55, which equals 0.2879. So to find the angle measure, we're going to do the inverse again. So sine inverse of 0.2879 will give us 16.7 degrees. Okay, so now we have two of our angle measures. We know that angle A is 39.3. We know that angle B is 16.7. So we can actually use our properties of triangles to solve for angle C because we know there's only 180 degrees in a triangle. So the measure of angle C would equal 180 minus both of our angles A and B. So minus 16.7 minus 39.3. So the measure of angle C would equal 124 degrees. Okay, so now we're going to move on to another example. Here we've got triangle ABC, and we're given an angle measure and two side lengths. So we've got the example of side, angle, side. So we have our information here where angle B is 10 degrees and 35 minutes. Let's quickly change that to a decimal. It's easier to deal with. So instead of 35 minutes, we're going to use 35 over 60, and that gives us 0.58. So it was actually 10.58 degrees that we're going to be looking at for angle B. And we know side length A is 40 and side length C is 30. Notice how I have my triangle set up here. A is opposite the longest side here, and there's a chance that A could be an obtuse angle. That's going to come into play as far as our order for how we're going to solve the different angle measures and side lengths here. But first, we're going to have to use law of cosines because we're in the side, angle, side manner here. So we need to solve for our other side length b. So we're going to use our formula b squared equals a squared plus c squared minus 2ac times cosine b. So just plug everything in here. You've got 40 squared plus 30 squared minus 2 times 40 times 30 times cosine of b, which is 10.58 degrees. So when you plug all of that into your calculator, you end up getting b squared equals about 140. So b equals approximately 11.8. So now that we have our side length and we have an angle measure, we can use the law of sines to solve for our next one. And remember, I said that the order that we're going to do this matters. So just a tip for you guys. Usually it's easier to solve for the shorter side length because then you're not going to have to deal with any obtuse angles, and you can use those two angle measures to solve for the third angle. And that's what we're going to do here. So we're actually going to solve for angle measure C next. So setting up our law of sine ratio, we have sine of 10.58 over 11.8, that's the side length B, equals sine C over 30. So when you cross multiply and divide, you're going to end up getting sine of C equals 0.4668. Take the inverse of 0.4668, so actually that would be sine inverse of 0.4668, and the measure of angle C equals 27.8 degrees. Now we can solve for angle A just using our properties of a triangle. So we know that it would be 180 minus 10.58 minus 27.8, and you end up getting the measure of angle A equals about 141.6 degrees. Okay, so we've solved everything that we need to for this triangle. Now we're going to move on to one last formula. And that's an area of any triangle. And this formula is that if you know the side lengths of any triangle, you can solve for its area using the following formula. And that is the area equals S times S minus A times S minus B times S minus C, where S equals A plus B plus C divided by 2. So as long as you have all three side lengths, you can use this formula. It's called Heron's formula to solve for the area of any triangle. So for example, we have triangle ABC. Let's say we have side lengths 12, 15, and 9. So when we plug this into our formula, first we need to solve for S. So S equals A plus B plus C all over 2. So plug that into your calculator. 12 plus 15 plus 9 divided by 2, and you end up getting S equals 18. So now we're going to use this into our formula. So that means we have the square root of 18 times 18 minus 12, so that will be 6, times 18 minus 15, so that's 3, times 18 minus 9, which is 9. So you take the square root of all of that, so the square root of 18 times 6 times 3 times 9, and you end up getting 54. So this triangle has an area of 54 units. And that's how you would actually use Heron's formula. So I know I went through that quickly, but I wanted to make sure we kept this video as short as possible. So there you go. That's all we have for today, and I will see you guys in class. Have a good one. Bye-bye.